In this video, I introduce support vector machines for machine learning. Suppose that we have a p-training data pairs from x1, y1 to xp, yp, where xi is a sample and yi is a corresponding label. Yk is 1 if xk belongs to class A, and yk is minus 1 if xk belongs to class B, as shown here. A linear discriminant model D X is defined as W times X plus B, where W and B are model parameters. The model is trained to find the model parameters using the labeled training dataset. The trained model can predict the label of new input X unseen during training, namely X belongs to class A if D larger than 0 and belongs to class B otherwise. There exists many discriminant lines to separate the samples into class A or class B. Suppose vector machine finds a hyperplane and support the vectors to maximum the margin. SVM finds the model parameters W and B to determine the hyperplane using the labeled training dataset. Hyperplane is defined as D is equal to 0. Discriminant function D determines the distance from samples to hyperplane W. If the hyperplane exists, a margin of hyperplane to a sample is indicated as M. The model is trained to satisfy the inequality here, where W times X plus B equal larger than 1 when Yk is a positive 1, and W times X plus B equals more than negative 1 when Yk is equal to negative 1. To find the optimal M, we need to solve the constraint problem below to find the minimum W. Lagrangian multiplier method is applied to solve the constraint problem above, namely minimizes the Lagrangian error subject to a constraint on alpha. Here, our goal is to find the minimum W and the maximum alpha. Using this relationship, we rewrite the constraint problem as here. The optimal W and B are computed by using gradient descent. Take a gradient of L with respect to W. The optimal W is computed here. The gradient of L with respect to B, the optimal alpha is computed from this equation. When alpha in the due space satisfies this equation, B reaches the optimum. In the due space, the optimal parameters W and B are substituted in Lagrangian error to get a Lagrangian error D for the due vector alpha. Given the constraint on W and B, Lagrangian error D is optimized to find the maximum alpha. Using this relationship, the maximum problem with two constraints is written as here. For a strong duality, the solutions are the same in the original space and in the due space. Namely, the objective function in the original space is the same as that in the due space. Given the optimal alpha in the due space, the optimal W in the original space is also solution to this equation. The equation shows that optimization in the dual space only needs to compute the inner product, which is known given a training dataset. In the dual space, inner product of training samples is known. Computing gradient of LD with respect to alpha, the gradient descent method is applied to update parameter alpha until convergence. Solving max LD in the support model is simple because there exists a small number of support vectors, namely alpha equal larger than 0 support vectors and smaller than 0 otherwise. With randomly initializing alpha, the gradient is used to update alpha. After obtaining the convergent alpha, the optimal W is computed from this formulation. For a new sample X, SVM predicts is a label using the discriminant function D here. For more details, please check with these references. Thank you. Bye.